So we're in chapter 4 of the OpenStax statistics book, and we're going to talk about computing probability from binomial distributions. So you can reference the OpenStax text for free. There is a link in the description of this video, and then the workbook that you're going to see me use, that's also totally free. You can check the description for a link, or you can go to my website, divideandconquermath.com. Just go to the chapter 4 area of the OpenStax statistics section. Okay, so for this one, I have some questions on the slides, but so I have also the question just here just for our reference. We have a coin has been altered to weight the heads outcome from 0.5 to 0.25 and is flipped 5 times. So we're going to let x equal the number of heads in 5 flips, and so we have x takes on the value 0, 1, 2, 3, 4, 5. So notice here I have this probability, I have this table with those outcomes, 0 to 5. And so we're asked a couple of questions here. What is the probability of getting more than 3 heads, more than 2 heads, and the expected number of heads in 5 flips? Okay, so the purpose of this tab's actually already filled out. But I wanted for you to have the opportunity to see how one of these tables is set up. And oops, if you can't see this box, by the way, there's another box down here. So in case my Excel look like this. So if you can't see this all the way, this is going to be helpful to you. So just expand that on your screen too. Okay, so anyways, so the whole point of having this tab filled in is so that you have a reference, because this is kind of a weird thing to see the first time. So you can see here that I actually have all of these probability formulas already filled in for us. And so these match the values on this table here. So these are the correct values. So how would I compute probability is really the thing that I want to show you, and then we'll do an original example after that. So to set up a probability density function, or to really compute the binomial formula, so here is the binomial formula. So you don't have to recreate this formula. Excel actually has its own formula for it, but it's important to understand the structure of it. The things that you need to know are you need to know n, which is the number of trials, which in this case would be 5 trials, x, which is the situation that you're interested in. So in this case, my x's would be 0 to 5, 0 heads, 2 heads, 5 heads, etc. And then you have your P and your Q. So P is your success, Q is your probability of failure. And we've talked about in the slides, you can review the slides that I have for this. Those are free also on my website. But success and failure is not a judgment, right? It's not like, oh, success feels like heads or tails or whatever. It's just how it's kind of worded in the problem. And since this problem is interested in the outcome of heads, that's what we're going to call a success. So one thing that you're going to want to do is you want to get in the habit of writing down the values so that you can see what they are. So notice I have P, Q, and N all listed here. My P was that 0.25, and then Q is always going to be 1 minus P. So I could put in 0.75, or I could do 1 minus 0.25, which would be 0.75, and then my N will be 5. You want to get in the habit of having these values broken out for when you write the formula. Okay. So the nice thing is about Excel is that we don't have to compute this formula. Excel actually understands that the binomial distribution is something that you want to use regularly. And so it has a binomial distribution formula, namely Binom.DIST. And so the things that you're going to input in for the prompts are what X value you're interested in, your N trials, what your success P is, and then you always end this with false. Just always end it with false when you're making your PDF table. I'll just say that for now. Okay, so look at how I've set up my formula. So I'm going to click here, and I'm actually going to look at the formula bar so that I can see all the colors broken out. So in my formula, so remember the first value is supposed to be that x. So the x here, so see how it's going to 0, so that makes sense. And then we have the N trials are next. So you can see here that I have the 5. And notice that I put $signs around that cell reference because I want it to stay locked. The next thing is going to be the P. So you can see here I've selected my P, again, $signs around it, and then I've got the false. So if I go through how I've set up this formula, you can see that I wrote it in such a way so that it can be dragged down and just reference those repeated values. This is how you set up your binomial distribution table. You do this every single time, so you have a reference to kind of get started with. And once you have the table, all the other questions get much easier. So like, what is the probability of getting more than 3 heads? So more than 3 heads would mean 4 or 5 heads. So you can just sum up those two values. And I can see here actually, you can see that Excel does this automatic sum thing down here. So this is like a 0.0156 chance. So I could say that this is, you know, I could enter that in, 0.0156. What is the probability of getting exactly 2 heads? So that's case where you have exactly 2 heads. That would be 0.264. The final question is, what is the expected number of heads in 5 flips? So that is so that's an expected value. So we'll just put that over here. So for an expected value formula, when you're talking about the binomial distribution, so that is always going to be calculated n times p. So I can just multiply those two things together, and that's going to be 1.25, and that's going to be the expected number of heads in 5 flips, okay? Okay, so this is the idea, and now what we're going to do is we're actually going to do it on the next tab. We're just going to build one from scratch, binomial distribution 2. Okay, so there's a few other questions on the slide if you're using my slides, and I've just gone to the part that has to do with making a table. And this is kind of an interesting one, actually. This shows the power of Excel, so I like this. So I have this art supplies catalog has 560 pages. 8 of the pages feature signature artists. Suppose we randomly sample 100 pages. Let X equal the number of pages that feature signature artists. We're going to use Excel to kind of build this, and then we're going to answer all these probability questions. Okay, so this is an interesting problem because it's actually, you have to figure out a lot of stuff about the binomial distribution from the context clues. So first of all, we're selecting 100 pages. And so what is that going to be? That's our number of trials. So in 100 pages that we've selected, we're wondering the question, does it feature the signature artist, right? So what is the probability that your page features a signature artist? That is 8 out of the 560 pages total. So my P is going to be 8 out of 560, and my Q will be 1 minus my P. So I've set this up so that this is 8 out of 560, and then my Q is just 1 minus that. So there's my P, Q, and N. Okay, so now we can, you might like have to flip back and forth between the two tabs to kind of wrap your head around this. But remember, your X's are what happens with each trial. So this is what I did before. This was the simple case of 5 trials. Now I have 100 trials. So what I'm going to do is I'm actually just going to set up a table from 0 to 100. But remember, oops, and sorry, 0, 1, 2, sorry, haha, I can't count. Okay, so anyways, okay, so I go 0, 1, 2. I'm going to drag this all the way down to 100. So remember, we have that nice little feature in Excel. We just drag everything down to 100. So, okay, so here are my 100 pages. And now what I'm going to do is I'm going to use the binomial distribution. And once again, so I've got the binomial distribution formula. Sorry, mine got cut off here. So if yours got cut off, here are the little prompts to help you with it. And let's see, I want to center everything because that's just what I do. Okay, so I'm going to use this Binom.DIST formula. So these prompts are helpful to know because what Excel shows you is going to be a little bit different. So this wants to know what X value are we talking about? What is our number S? So you can see that my formula has gone over the 0 that I want to use. So when that happens, you just click on a random cell and then you can arrow down. So I know that the 0 is underneath here and I can see that box kind of blinking, so we're good to go here. So that cell needs to kind of move around freely. The number of trials that we had was 100. So remember I had PQN. So again, I can't see the N, so I'm just going to arrow down to it. But in this case, that E3 needs to be locked. So I'm going to hit the F4 key, or I'm going to put a $sign in front of the E and the 3. And so now we're good to go there. Okay, so there's the number of trials. And so again, I've got these little prompts to help me out too if I forgot. Next, we have what is the probability of success? So you can kind of think of this as, you know, this is the number of pages, and then here's the here's the probability that that particular page, I guess, will have it. So anyways, so this is going to be my P, and I'm going to lock that as well. So I've got $signs around everything, and then I always just write false. Okay, so now I can calculate this probability all the way down. So I am just going to double click, and remember, so I'll show you that one more time. So just remember the keyboard shortcut after you put in a formula. So there's a keyboard shortcut that after you have, the amount of data kind of listed like I do here, if you just double click on that X, that will auto populate all the way down. So a very interesting thing happens as you look through these data values. These are now getting to very small values, and so what I'm going to do actually is I am going to round everything to a couple decimal points. So let's see. Oh, I'm having a problem here. Okay, so I'm trying to round this to a couple decimal points, but it's not looking pretty. So I'm going to click on number, and that fixed it for me. So now I can see I've got this out to 3 decimal points. So I just selected all my data, and then I went here and I went to number, and then I just expanded it out to 3 decimal points. Okay, so now I have to think about if this actually makes sense here for a second. So what this is saying is that if I go through pages 1, 2, 3, 4, 5, 6, 7, 8, so you can see I have these different probabilities, but once I get to 8, my probability basically hits 0, and then anything after 8 is all 0. So the question is, what does this mean, and does it make sense? So I wanted to examine what happens for all 100 pages, but how many pages had the signature artist? It was only 8 pages that have the signature artist. So out of 100 pages that I'm selecting, in the best case scenario, only 8, like in the best case scenario, I would have selected those 8 pages from the signature artist, right? There's no way, if there's only 8 pages total that feature signature artists, I cannot get 36 signature artist pages, right? It just doesn't exist. So part of this, like when you get these results, you want to take a second to ask yourself if that actually makes sense. Yes. And then this is saying that the probability that all 8 pages feature signature artists, that's like pretty rare because we've selected 100 pages in total, right? So the idea that I would have 0 pages with the signature artist, that's a 23% chance. The probability that 1 out of the 100 pages would have a signature artist is 34%. This means the probability that 2 pages would have 2 pages out of the 100 would have the signature artist, that's 24.7%, so on and so forth. So that's what all of this means. You kind of got to wrap your head around this. So now that I'm here, I can answer these questions. So it says find the probability that 2 pages feature signature artists. Well, I can see now the probability that 2 pages feature signature artists, that's this 0.247, right? That's exactly what we're looking for. Then it says find the probability that at most 6 pages feature signature artists. Okay, so now that I have this table, this is actually pretty easy to compute. At most 6. So that means 0, 1, 2, 3, 4, 5, or 6. So those would be these values here. So if I wanted to, I could just sum these up, 0 through 6, and that comes out to 0.9999. So at most 6 have them. That's going to come out to this 0.9999, so pretty likely. And then let's see, let's do the third question. So the third question asks, find the probability that more than 3 pages feature signature artists. So more than 3, that would be 4 and above. So I can really just sum all this up again. So if I just sum this up, I can go 4 all the way down. And once I go past 8, right, everything's just 0. So I just really need these few decimals right here. I've just selected more zeros than I need. So this comes out to 0.056. And this is bothering me, so I'm going to move this 0.247 here because I like the symmetry of everything. Okay. So anyways, so all of these little probability questions are actually pretty easy once you have the table in front of you. And the table is actually pretty easy to set up, right? Because you're just kind of copying a bunch of formulas. The last questions are about the mean and the standard deviation. So remember, For the mean, you're just going to take n times p. So I'm just going to take 100 times my 0.014. So my mean is going to be this 1.428 and some change. And then for this other question, the standard deviation, so that's the square root of npq. So again, I can just set up an Excel formula for that. And I'm just going to take this n times this p times this q over here in the corner. And so then there's my standard deviation. And so that's all you have to do for that one. So it is a lot of work, and you kind of have to wrap your head around it. But they are kind of fun problems to do because it seems like these really hard things, but when you have Excel, it's really, really handy.